So good morning, everyone. There are no technicians available at this moment, so I will record the seminar on my smartphone. So it's not the best way, but that's the best I can do at the moment. So today we will talk about the decision making under uncertainty. The handout to this seminar will be available, of course. It's not completely finished because I didn't have time enough to prepare all the applications which I would like to cover with you, but I will finish it later. So the first applications on the in my handout looks like this. We have the utility function from wealth, and we know the initial wealth of the house, or the initial wealth of the person, which is the ownership of the house, the value of which is 10 million crowns. And we know that if there were some fire, the wealth of the person would reduce to 1 million because the house would turn into ashes, and the only thing which would remain would be the land property, the value of which is 1 million. We know that the probability of the fire is 10%. We are supposed to compute the expected wealth of this person, expected utility of the house, and the maximum insurance payments that the person is prepared to pay, and to capture all these values in the graph. So first of all, let me do some introductory conceptual review and explain to you which abbreviations I'm going to use and what's actually the point of this decision making. Until this moment, we have discussed always that the consumer is deciding between X and Y, or between some combination of X and Y and some other combination of X and Y. But we assumed implicitly that the consumer is sure about the fact that if he chooses the combination, he will get it. So there was no uncertainty in the decision making. But in real life, it's not this way. And it doesn't work like this because in many cases, it happens that we assume that we will do some kind of exchange, that we will have some income, but in the end, it will not be our income because something happened which simply broke our plans, and which changed our final income in some way. And if we do not know what exactly is going to be the result of our actions, and we only assume that there is a probability that our actions will be successful, we need to take this uncertainty into account when we are deciding. And this is exactly what we are going to talk about today. The first thing I would mention, I would say and put stress upon, is that the function which we are going to work with is called the utility of wealth. Why not wealth? Why utility of wealth? Because it's the utility of money, of house, of car, which we want to maximize. So we don't want to maximize the amount of money in our possession. We want to maximize the utility from the money, because it's not the money which is relevant for us in itself. It's the utility from the money, which can sound like strange, but it will make sense when we distinguish two kinds of people. Let's say that I am, as we will call it, risk averse. It means I don't like risk. I don't like taking risks. So if someone gives me two options, I will give you a gift. Either I will give you 1,000 crowns in cash, or I can give you a lottery which can win 1 million crowns, but the probability that it will happen is only 0.1%. Which of these two options would you prefer? Well, it's not so clear to answer because we don't know our utility function from the wealth. But in one case, it's easy to explain, it's easy to decide. Let's say that I would tell you, I can either give you 1 million in cash, or I can give you a lottery ticket, lottery bill, for 1 million, where you can win with the probability of 1%. Which of these two options would you prefer? Most of us would probably prefer the 1 million in cash rather than the chance to play for 1 million, where the probability that you will win is very small. Because why? Because we are risk averse. We don't like the risk. So if you have the option to have something for certain, with certainty, or something with less certainty, we prefer the certain thing to the uncertain thing. But there are people who like risk, who like risking and taking risks. For example, it's a stupid example, but there are some people who steal money in the magazine, in the shop, not because they need the things, but because they like the adrenaline which is produced by the fact that I could be caught by the owner of the shop. So I steal it just for the feeling of the risk. In that case, we can say that it works the opposite way. The thing itself, which I can have, brings me less utility than the thing plus the risk that I could be caught. Because the game, the adrenaline, the risk that I could be caught in the process of stealing is something I prefer. So in this special case, and in this for this type of a person, the risk is something not positive, but not something negative, but something positive. It means that we call that person not risk averse, but risk loving. Obviously, the risk is something which goes through our internal mental processes and which is processed by our brain and by our nature. And in some cases, we prefer the risk as something positive. We consider it something positive. We are even able to pay for it. So the person who takes the risk is of course exposing himself to the risk that he will be caught, and it will be shame, and he could pay a fine or be put in jail and so on. But he takes the risk because he loves the feeling that he could be caught. So the thing which he steals plus the risk is more than the thing itself. But in usual cases, it's the opposite way. If we can have something for certain, like house or car or money, we prefer it to have it like with certainty, rather than to being given the option to play a game for the thing. Does it make sense like this? Okay. Now, for the risk averse person, the utility function from wealth looks like this. It's concave. Maybe it's not understandable why it's so in this case, but it will be more understandable later. I'm thinking like maybe I hope it will be possible to in the video to mirror change the is it possible to do it?
I think, yeah.
Yeah, because it's like it's reversed. Okay, so I will do it later. Okay, so this is the risk averse person. It will be understandable later why it looks like this. For the risk-loving person, the utility function will be looking like this. Wealth, utility of wealth looks like this. It's the risk-loving person. Risk-loving person. Okay. Now, if you knew that you can get something, and you knew that you will get it, so you would have the certainty. For example, I would know that my wealth will be 1 million. Then my utility would be like this. Utility from the 1 million. Okay. But then, if my wealth increases to 1.5 million, the increment to my utility will be lower than, or as compared to the situation when I had 500,000 and I increased my wealth to 1 million. The increment was the same, plus 500,000, but the additional utility from this increase is now lower. You can see it here. This is the increment to the utility. And the richer I am, the lower the increments to my utility from the wealth are. So my marginal utility, as we say, we call it, is decreasing. Each dollar, each crown, each million brings me a lower utility than the previous million or previous 1,000 crowns. Which is also natural, I think, because if you didn't have anything, if you were a complete beggar without anything, with a single dollar, the first dollar would probably bring you higher additional utility than if you have $1 million and someone would give you $1. In that case, the marginal utility is very small. Okay, now if in case of the risk-loving person, it will be the opposite case. Each additional dollar will bring you a higher utility than the previous dollar. Now, it's still not clear why this should be related to the risk aversion or risk-loving nature of the person, but it will be clear in a moment. Now, let's take a look at one concept, very easy concept. It's the expected wealth. So let's say that I would have, can I erase this? I would have a value, some of money. So let's say lottery, where the win is 5,000 crowns. If you lose, you would lose only. You would lose, let's say 2,000 crowns. You lose 2,000 crowns. And the probability of win would be 0.5, means 50%. And probability of lose will be also 0.5. There's no third option because simply you will win or lose. And the question is, what is the expected wealth or expected value, generally expected value, let's call it expected value in this case. Expected value of this lottery. So As you might guess, it will be a very simple calculation. Probability of win plus probability of the lose equals the expected value. 0.5 times win plus 0.5 times lose means minus 2000, which is 2,500 minus 1000 equals 1500. It's higher than 1. It means it pays off to have such a lottery, to get such a lottery makes you better. What if I changed the setup? Let's say that the win would be let's say that the win would be 4,000 crowns. The lose would be 3,000 crowns. No, 2,000 crowns too. And let's say that the probability of win would be 0.25. Probability of lose would be 0.75. Thinking. This were 1 quarter would be 1,000. 1,000 would be like 4,000. In that case, the expected value would be 1,000 minus 1,500. Correct. So it would be like minus 500. In that case, it will be 0.25 times 4,000 plus 0.75 times minus 2,000, which means it will be like 1,000 crowns minus 1,500 will be minus 500, negative. So this is a game where, on average, you will lose. The first game was a game where, on average, you could win. The positive expected value, negative expected value. So the question is, if I were supposed to play a lottery where the positive expected value is the case, I would be willing to play such a lottery, because on average I will win. But if I were supposed to put my money, to bet my money on a lottery where on average I will lose, I would not do it. And then there is a third case of the lottery where, you see, where it would be, how much is, if I had 25% of 4,500, how much is it? How does it work? I need to have such a value of win so that 25% of it is 1,500. It means that it's 6,000. Okay, so let's have 6,000 crowns. Visible? Okay. 6,000 crowns win and lose 2,000. And the probabilities are still 0.25, 0.75. In that case, the expected value of such a lottery would be 0.25 times 6,000 minus 0.75 times 2,000. It means it would be 1,500 minus 1,500, which means 0. Which means that on average, I would not win, neither lose. Such a game is called a fair game. Fair game. Fair game is a game where, or lottery, where on average I will neither win nor lose. So if you put your money in the lottery, where on average you can neither win or lose, you can say that you will be indifferent whether you will play such a lottery or not. But it's not completely true. And it's also not completely true that you will always prefer the lottery where the expected wealth is higher. Let's say we would have two lotteries. Lottery where the expected wealth is 1,500 and a lottery where the expected wealth is 2,000. Maybe we would have the tendency to say that the lottery with the expected value or expected wealth is higher is more preferable. But it's not true. Why? Because what we want to maximize is not expected value or expected wealth of the lottery, but the utility from the lottery, which is a different concept. Okay, let's take a look at it. Can I erase the board now? Okay. So, let's say, and we can use the application from our handout actually. We have the utility function of wealth as the square root of W. So it's a typical concave function where each additional dollar brings you higher utility than the previous, like lower, the additional dollar brings you lower utility than the previous dollar. So with W increasing, the utility is increasing, but the rate of increase is decreasing itself. So the increments are smaller and smaller. So it's a concave function. Now, initial wealth, let's say it's a house, is 10 million crowns. And the game, or lottery in this case, is will there be a fire or will there not be a fire? Lottery means something is uncertain. So it can be like a game, but it can also be like a real life situation such as a fire of the house. So if there is a fire, there will be reduction in my wealth to 10 million crowns. 1 million crown, because the only thing which will be left will be the land property below the house, beneath the house, and the house will burn to ashes. So I will only have the land property without the house, and the probability of the fire is 10%. So now, what is the expected wealth or expected value in this game? So it will be the probability that I will win plus probability that I will lose. Now, if I will win, the probability of win times the expected return, a new concept, expected return if I win plus probability of lose times expected return when I lose. Now, how much is the probability that I will win? It means there will be no fire. 90%, so 0.9. If there is no fire, how much will I win? Actually, no. If there was no fire, I will not win anything. I will keep my land property and my house. So the additional wealth will be 0. But that's what I'm actually trying to have, actually, to keep my house. So that's good, that it's 0. But if I will lose with the 10% probability, the loss will be 9 million value of my house. I will lose 9 million. So the expected wealth is 0.9 million minus means it's expected wealth. This was supposed to be actually the expected return. Yes, so my mistake. Sorry. This was the expected return actually. Expected return. The total expected return. I mean. So the total expected return. The total expected return will be my expected return if I win times probability of the win plus expected return of my lose times probability of the lose. So the expected return will be minus 900,000 crowns. Minus 900,000 crowns. Now, expected wealth, which I actually wanted to discuss before, will be what? Simply my initial wealth, W0, plus expected return total. It means 10 million minus 0.9, it means 9.1 million crowns. So on average, my house and land property have the value 9.1 million crowns. If I take into account the risk that I could lose it and the probability is such and such. Okay. Now, if we capture graphically, so this is the wealth, utility of wealth, concave function square root of W. Now, the initial wealth was 10 million. The W0. Which is also the wealth in case that I would win. It means if there was no fire, I would have this. And if there were fire, there is no fire, I will keep this. If there is fire, I would have only 1 million. Now, the expected wealth is somewhere here. 9.1 million is the expected wealth of my house. Right. But if I want to, so we have the expected wealth now calculated. But the other question is, what's the expected utility of the house? Which is subjective, because this is the basic difference. Expected wealth is objective. It can be calculated without any regard to what's my or your utility function. But if you have a utility function, it's subjective. It's how you feel. It's about feelings, but subjective emotions and so on. Everyone has a different utility function. Now, what's the utility of the house if we take into account the uncertainty, as we call it, the expected utility? From the graphical viewpoint, the expected utility will be here. This will be the expected utility of the house. Now, what is this point actually? What's the difference between the expected utility of the house and the utility of the expected wealth? The difference is simple. The EU is the utility of something I have no certainty about. So it's the utility of the game. But the utility from the value 9.1 is the utility of the money if I had it certain. So if I knew that my house will have the value 9.1 objectively, and there will be certainty on my side, there's no fire, and I knew that the value is 9.1, my utility from the house would be 9.1. But I had no such certainty, because I know that this can happen with 10% probability, and this can happen with 90% probability. So my uncertainty is captured in the graph by the point on this chord. If you know the concept of chord, so if you have a visible here? Okay. If you have a circle, so this would be called a tangent line. Tangent line. Which we used and introduced last time when we were discussing the derivatives and so on. But this means the section which is interconnecting two points on the arc actually is called chord. So the uncertainty, the game, is always on the chord, and on the arc is always the certainty. That's rule number one, which is simple to remember. So on the arc we have the certainty, and on the chord we have the game. Game means uncertainty. Okay. And in this case, what would the person prefer? To play a game for 9.1 million, or to have 9.1 million for certain? What's the higher value? The certain 9.1 or the uncertain 9.1? It's obvious that the certain 9.1 million would be better for him than the uncertain 9.1. That's when we have the risk-averse subject. You can imagine what would happen if we had the risk-loving subject. Just to compare it. If we had the risk-loving subject, and we had the same situation, 1 million, 10 million, 9.1 million. So this will be the certainty. but the uncertainty would be here. Can you see? So this is the reason why the concave function represents the risk-averse person and the convex function represents the risk-loving person. So this will be the utility, expected utility of the game, and this will be the utility of the expected wealth. This will be the risk-loving person. And this is the risk-averse person, such as anyone with the concave utility of wealth function. Risk-averse person. Okay, that's a graphical representation. But because we know the function, we can calculate it precisely. So, let's do it. Let me erase the lower part of the board now. I will only leave the upper part. Now, how do we do it? We simply take, if we want to calculate the expected utility of the game of fire, we do it like this. We take the wealth in case of lose. And we calculate the utility of it times the probability that this will happen plus the wealth that I will win. It means nothing will change. I will keep my house, 10 million. The utility of this sum of money times the probability that I will have this sum of money. Okay. Because I don't have the calculator because I'm using my smartphone. Please help me out. So the utility lose is simply wealth of lose is 1 million to the power of 0.5 times 0.1 plus 10 million to the power of, not 0.5, 0.1 actually, because the probability is 1%. And this win is 10 million to the power of 0.9, because 90% probability there will be no fire, times because it's the square root, so that's why it was 0.5. So yes, and this is the probability. So this is the same as this actually, but only the calculator cannot doesn't know. Actually, it's like my calculator, maybe yours will, but I have to type it in the form of the value to the power of 1/2, which is 0.5, and this also, and the result is
1000 multiplied by 0.1. Because it is like square root of 1 million, right?
Oh, 1 million, yeah.
So it's 1000, no? It should be.
I think so, because 1000 times 1000 is 1 million. Okay, which means times 1 is 100 actually. 100, okay. Plus, and 10 million, well, it will be like...
It's 3,162.278 multiplied by 0.9, which will be 2,846.05.
2,846.05.
05.
05.
Yeah.
Okay, so the expected utility, the number doesn't tell us anything actually. It's a subjective number which we only can compare to some other number. So okay, so some number 2,946.0.5 is this actually number. So the 2,946.05. And we can compare it. How much is the utility of the 9.1 million? It's actually 9.1 million to the power of 0.5. Please. It should be higher number.
3,016.62.
So 3,060.
16. Yeah.
0.62. Okay. 3,016.62. So it is a high number. So if I could have 9.1 million for certain, I would prefer it to play a game for this sum of money. But I cannot, because I cannot afford it. I cannot avoid the risk. But actually I could avoid a risk. What do we call it if I buy a chance to avoid a risk? It's called insurance, exactly. Which is exactly what we are discussing in this particular application.
How did we get 3,016?
How do we get?
Yeah.
Actually, it's the utility from this sum of money if I had it for certain. So you place the 9.1 into the utility function. So it's the utility from this sum of money if I had it certain.
Okay.
Which means I don't have to multiply by any probabilities. It's awesome. Okay. Now, what's the maximum utility? The maximum insurance I am prepared to pay to someone who offers me the option to eliminate the risk. In other words, the insurance company offers me a deal that's okay. If your house will burn to ashes, I will pay you. I will pay you the 9 million crowns so that you will not lose anything. But if the house will not burn to ashes, you will pay to me until the end of your contract, insurance contract, you will pay to me a certain sum of money. Now, the sum of money is negotiable, of course, but what's the maximum sum of money you are prepared to pay to someone to help you avoid the risk? It should be a sum of money which, if you subtract from your initial wealth, will bring you such a utility which will be equal to the utility of the game itself. In other words, now if I am exposed to risk, my utility is 2,946.05. That's my utility from the house if I know that I am exposed to the risk of fire. If I pay the insurance, I should be better off. Or at worst, equal, same off. So my utility after deduction of the insurance payment should be equal to the utility if I am not insured. In other words, okay? In other words, if I get insured, I should be better off, or at worst, same off, as compared to the situation when I'm not insured. As compared to no insurance situation. So let's translate it into some kind of equation. So if my utility after I'm insured, so my utility from the 10 million minus insurance payments, let's call it insurance payments, my utility after I pay this will be sure utility, because there will be no risk anymore, because that's what's the point actually. After I pay the insurance permit, I don't have to be afraid that there will be a fire, because even if there were a fire, I will get my money back. So my utility after deduction of this insurance payment should be higher or at worst equal to the expected utility of the game fire. Which means my utility, and utility is what? It's the square root of a sum of money. So the square root of the 10 million minus the insurance payment, which is the utility from the money I am left with after I subtract the insurance payment, should be higher or at worst equal to the 2,946.05. Now, it means that if I empower both sides of the inequality to the power of 2, I will get, let me continue here, I will get 10 million minus insurance payments higher or equal to 2,946.05 squared, which means the IP insurance payment will be lower equal 10 million minus 2,946.05 squared. Okay. Please, how much is the 2,946.05 squared?
8 billion.
8 million.
679,210.
Okay, 8 million point.
679.
679.
210.
210 object. Actually, okay, that's enough. Which means that the insurance payment must not be higher than, please, calculate this. How much is it?
$1,320,000, 1.320.789 and
One second, please. 1,320,789
789 0.398.
Okay, let's round it up to the crowns. Okay, so the insurance payment in this case would not be allowed to be higher than 1,003,020,789. Of course, it's not for 1 year. It's like the total insurance, which can be divided by the number of years, and after some arrangements with the related to the temporal value of money, would bring us the 1 year insurance payment. But this is the amount of money which I'm prepared to pay in total across time for this contract. And where is it actually? Well, if it is exactly equal, it means that this utility will be the same utility as if I subtract the value. And after the payment of the insurance, do I have the money certain or not? I have, so I'm on the certainty arc. So I will be here. So here would be the 8,679,210 and so on. So this value would be the maximum insurance payment, equal to 1.320789 million. Once again, it's not 1 year insurance payment, it's the total insurance payment, which can be divided into the number of years of the insurance contract, which can be 20 years, 30 years, depending on for how long I want to be insured. So the maximum insurance payment will be such a sum of money that if I subtract the sum of money from my initial wealth, I will get a certain sum of money, the value of which will be equal, or the utility of which will be the same as the utility from the game itself. So it's about indifference. Indifference. It's the same as if which means that, of course, I, as an, what do they call it? Insurer, maybe insured person. Sure, I'm not sure. Actually, will be the lower it will be, the better, of course. But the maximum will be this. If the insurance company wanted a higher insurance payment than this, the insured person would say no, thank you. If it is lower, okay. Okay, it's not here, but we can extend the problem by calculating. So, what's the minimum insurance payment which the insurance company will insist on? What's the minimum insurance payment which the insurance company needs to get to be willing to accept such a contract with the insured person? Well, logically, it must be at least the value of the expected loss of the expected damage, which is what? 10% that you will actually lose 9 million, which means the 900,000 crowns. So at least it must be 900,000 crowns. Of course, it must be more because the insurance company must pay the workers or the employees, plus it must have some adequate profit and so on and so on. But the minimum insurance payment for the company must be at least the value of the damage which it is supposed on average to pay to the insured person. So we can extend the problem by adding one more question, which is, what's the minimum, or they also call it fair insurance, what's the minimum insurance? We use the green color. What's the minimum insurance payment or fair insurance payment? It must be the expected loss expected damage, which is 0.1 times initial wealth minus the wealth in case of fire. It means it must be 0.1 times 10 million minus 1 million. It means it must be equal to 900,000 crowns, which is exactly this section. Minimum.
The 0.1 in this equation is the probability of fire, right?
Probability of fire, exactly. Yeah, it's the probability of the loss. Okay. So, if you understand this, there's not much more. The other problems and applications will be just extensions or some modifications of this. So, the basic point, the basic thing to understand is that the certainty is, for this type of person, preferred to gain. That's why we have the difference between uncertain money and certain money. Certain money is better than uncertain. That's why always will preferring the sum of money on the arc as compared to the money on the court. If I have the same sum of money, so the same sum of money on the arc will be better than the same sum of money on the court, because the court means uncertainty, but the arc means certainty. Okay, let's take another problem, which is very similar to the first one, but it'll be a good training for us. So let's practice it. Can I erase the water? Okay. So the second problem, utility of wealth, or the utility of wealth function, is slightly modified. I have multiplied by 2, so it's a bit. It doesn't look like this, but more like this. But basically, it's the same type of function. So it's a concave function, which represents the subject which is risk averse. Now, the initial wealth of the person is the car which the person owns, of the value 1 million crowns. In case of a car crash, the value of the car would reduce by 80% to only 0.2 million crowns, because the damage caused to the car. The probability of the car crash, let's say, objectively, is 5% only. Now, again, let's calculate the expected wealth of the person. It means the expected wealth, the expected value of the car, if you wish. The expected utility from the car, which is subjective, unlike the expected wealth. And the minimum insurance payment that the insurance company will charge the person. We can also calculate, of course, the maximum and so on, and to capture it graphically. So let's do it. The same type of problem as before. So the utility is square root of 2w. And let's start with the expected wealth, which in this case is expected value of the car. Expected wealth will be equal to the probability that there will be no car crash no car crash, times the sum of money I would have if there were no car crash, which would be like the initial wealth, plus probability that there will be a car crash, times the value of money or value of my car if there were a car crash. It means expected wealth will be equal to 0.95. It's very probable that there will be no car crash. And in that case, I will keep my car with the value of 1 million. Plus there's 5% probability that my car will have a car crash, which means that it would reduce the price to only 200,000 crowns. Which means it would be 950,000 plus, how much is this please? 200,000 crowns, so 1% of it is 2,000 times 5, so 10,000?
Yeah.
Okay. So expected wealth will be 960,000 crowns. Now, what's the expected utility of the car? It means the subjective aspect of this problem. So the probability that there will be no car crash times the utility of my money or my wealth if there were no car crash, plus probability that there will be car crash times utility of my money after the crash, if there were some crash. It means of the 0.2 million. Or generally like value of the wealth if there is crash. So let's plug in the values. So it will be 0.95 times square root. We have the utility function 2w under the square root, so there must be the 2 in front of the w actually in this case, because we have this function. Okay, so it will be 2 times 1 million, so 2 million, plus 0.05 times square root of 2 times, so it's 400,000, 0.4 million. The expected utility, I will ask you for the calculation, please. It's 2 million to the power of 0.5 plus times 0.4 million to the power of 0.5. Final result, please.
1,375.1.
75.
Yeah. No, so 75.
75.
Yeah. 0.1.
0.1. Okay. Number which is no units, it's simply utility, so we don't care about how much the number is. We want to compare it to some other number later. Now, the minimum and maximum insurance. So let's start with the easier one, which is the minimum insurance, which is objective. The minimum insurance payment, as we said, is equal to the expected loss, expected damage, which is equal to what? 5%, and the damage. How much is the damage in this case? If there were a crash,
0.8 million.
exactly 0.8, because initially the car had the value 1 million, after the crash 0.2, so the difference is 0.8. 5 times 8 is 40, so it will be 0.04 if I'm not mistaken. Million. Which means 40,000?
Yeah.
40,000 francs. So the expected loss.
So technically, the minimum insurance payment equals to the expected return.
Exactly. But it will never be, the insurance company will never accept this, like in practice, because it has to pay its employees. It has some administrative costs which it has to cover, and also there must be some profit. So this would be only if there were no profit and no employees, just to be able to pay the damage. But of course, if there are some kind of like additional costs, it has to be more. But this is like the benchmark sum of money which the company must at least get. Okay. Okay, and now a little bit trickier part, the minimum insurance. Oh, like, okay, so let's draw a picture to make it more visually accessible. So, where is this? So, it's the risk-averse person again. $1 million here, no crash, and 0.2 million here if there is the crash. This is the certainty. This is the gain or uncertainty. Expected wealth is 960, so 0.96 million. Expected wealth. And the expected utility is the value of this section, actually. The distance between 0 and the point on the chord. Expected utility, which is, we said, 1,375.1. This is the minimum insurance, to 40,000 crowns. Minimum insurance payment. And now, what is the maximum insurance payment in the graph? It's a distance between this point and, or between this vertical line and the maximum wealth if there is no car crash. So this will be the maximum insurance. Because in this case, the insurance payment will be such that after paying it, my utility, which is certain, will be the same as the uncertain utility from the gain. Make sense? The certain utility will be equal to the uncertain utility. Uncertain or expected utility. So let's get it. We know that the maximum insurance is a sum of money which I'm left with after I pay it. Is a sum of money which I subtract from the 1 million. So 1 million minus the maximum insurance payment. But let's not forget about times 2 under square root, because the function looks like square root of 2w. We need to multiply by 2 in this case. And if we are exactly in the case of equality, it will be equal to the utility 1375.1. Okay, so what do we do now? Empower both sides of the equation by 2. So it's 1 million minus maximum insurance payment times 2 equals 1375.1 squared. Now, it's 2 million minus 2 maximum insurance payments equals 375.1 squared. So it's 2 maximum insurance payments equals 2 million minus 1375.1 squared. So the maximum insurance payments will be 2 million minus 1375.1 squared divided by 2. How much is it, please?
54,500. 49.995.
Okay, so 45, let's say. 50. Crowns. So the maximum insurance in this case will be the 54.35 thousand crowns to eliminate the risk. So I know now that even if I had a car crash, I would still get the 800,000 difference back from the insurance company. But in exchange for the certainty, I pay the 55,000 crowns to the insurance company. Of course, why is it profitable for the insurance company to accept such a deal? Because it's not probable that all its insured clients will have the car accident at the same time. If they had, of course, it will be a collapse of the insurance company, but it will probably not happen that 1 million clients of the insurance company will have the car crash at the same time. So probably only, let's say, 5% of the insured insured clients of the company will have the car crash. Not more than 5%, because on average the probability is 5% that you will have a car crash. So not more than 5% clients should have the car crash. So even if it is the worst case scenario, the company will be able to pay the compensation to all the clients who were bad luck. And if the insurance is higher than 40,000, it will also have some profit on top of it. Okay. Anything you want to ask? Anything else clear? To get it back to something? Okay. One more thing, but I'm not sure we have 4 minutes. I don't know if we have time to finish it. Probably will not finish it completely. So maybe I would leave it for the next time, because I will get back to the problem, get back to the topic. I will add some other applications which I didn't have time to cover today. I will get back to it. In the meantime, you can digest the acquired knowledge a bit before we will continue. Okay, thanks for coming today, and sorry for the trouble again. And next week, Wednesday morning, if I can ask you, we'll continue. Okay, thank you.
Yeah, sorry. Next Wednesday we'll have like the test or the same.
Yes, there will be the test, which I would like to start with, and after, let's say, 35 minutes or so, we will continue with this and other topics.
Okay.
Okay, thank you.